multiply k squared plus 11k plus 24 over k squared plus 17k plus 72 times k squared plus 9k over k squared plus 12k plus 27. So the first thing that we do is factor all of the numerators and all of the denominators. So what we can do, since the leading coefficient of the first one is 1, we can use the shortcut. So we look for the factors of 24. So what multiplies to equal 24 and adds to 11? So that would be 8 and 3. So that would factor to k plus 8 over k plus 3. Now we look at our denominator. And again, the leading coefficient is 1. So all we need to do is look for the factors of positive 72 that add to a positive 17. So 9 times 8 is 72, and 9 plus 8 is 17. So this would be k plus 8 and k plus 9. So now we come to our next numerator, the k squared plus 9k. Remember, the first step in the factoring is to remove the greatest common factor. Since both of these terms have a factor of k, we factor out the k, which would leave us with k plus 9. For our last denominator, again, the leading coefficient is 1, so we look for the factors of a positive 27 that add to a 12. So 9 times 3 is 27. And 9 plus 3 is 12. So this factors to k plus 9 times k plus 3. Now we reduce. So what I'd like to do is just to extend the fraction bar. So anything in the denominator, any factor in the denominator, can reduce with any factor in the numerator. So here we have like factors of k plus 8, and when we reduce, remember, it leaves 1 because any factor over itself is 1. We have a k plus 3, and a k plus 3, and a k plus 9, and a k plus 9. So in the numerator, we have 1 times k times 1, which is just k. And in the denominator, we have 1 times k plus 9 times 1, which is k plus 9. This cannot reduce any further because this k is not a factor but a term. So our answer is k over k plus 9.